Welcome back, everybody. This is going to be the final of 3 parts in my lecture series on solving types of equations that aren't quadratic. If you haven't seen the first 2, please go back and watch those as they're going to be important for this video. In this one, we're going to talk about how to use a method called substitution to solve equations. Let's get started. What is a substitution? Well, a substitution is essentially just giving a new name to something that exists in the problem. In this problem, x to the 2/3 minus x to the 1/3 equals 6 is a really tricky problem to solve because of all of those thirds floating around in the exponents. Notice that if I had the simpler problem, x squared minus x to the 1 equals 6. In other words, if I just didn't have those thirds floating around, this would be a pretty simple problem to solve. A really common technique that we see in math all over the place is taking problems we don't know how to solve and bullying them until they look like a problem we know how to solve. So that's what we're going to do here. We're going to take this problem and bully it into looking like this. And the way we're going to do that is through a substitution. Now, a substitution is just when you give a name to something that exists in the problem. I don't like the 1/3 powers, but what I notice is the relationship between this problem and this problem is that I have an extra 1/3. In other words, there's kind of this intermediate step here where I've got x to the 1/3 squared minus x to the 1/3 to the 1 equals 6. So it's that x to the 1/3 power that's giving me trouble. So I'm going to call it something else. I'm going to call it u. Let's let u equal x to the 1/3. Then, everywhere I see an x to the 1/3 in my problem, I can write u instead. So, now I can write that x to the 2/3 minus x to the 1/3 equals 6 becomes u squared minus u equals 6. And that's the problem that we know how to solve. I simply move everything to one side. Oops. And then this quadratic equation I can factor, and I get u minus 3 times u plus 2 equals 0. And that tells me that u has to be 3 or -2. A common mistake would be to say those are the answers. But remember, I'm trying to find x values, not u values. So this is kind of the downside to our substitution method, is we've got one more step now, which is to borrow this equation again, right? This is the relationship between u and x. And given those values of u, 3 and -2, I need to find out what x values gave me those u values. And these are each tiny radical equations for us to solve. Go ahead and pause the video here to see if you can do it on your own. The final answers are -8 and 27. The way that I got that was, remember, to clear the radicals, I need to raise both sides to the reciprocal power. In both cases, that power is 1/3, so its reciprocal would be 3. I cube both sides to get x equals 27 on the left, and x equals -8 on the right. Now, this is a bit of a challenge for you. Go ahead and pause the video here to see if you can figure out what substitution is necessary in order to solve this problem, and then solve it. If you need a hint, I will show you that substitution here if you want to press play for just a minute. Ready for the hint? U should be y minus 8 over y. Notice that when I factor a 5 out of the next 2 terms, I'm also left with a copy of that. Now, if only that piece were something simpler, say u, I would be left over with a problem I know how to solve. See if you can pick it up from here. The final answer that I came up with was y equals -8, 1, 4, and -2. Go ahead and pause the video here to check my work if you need to. In this video, we looked at how to use substitution to solve problems. In the next video, we're going to take a look at how to solve equations that involve absolute values. Catch y'all in the next one.